What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 5.7, using congruent triangles. So we're going to be able to just use them and figure out how we can apply them to different situations. The first one we're going to talk about is how could you prove that angle A is congruent to angle C? One thing you can look at is you know that all three pairs of sides are congruent. I know that because AD matches CD, AB matches CB, and BD matches BD. Okay, so if I know that all sides are congruent, using the side congruence theorem, you can also conclude all three angles are congruent. So angle A is congruent to angle C. This next one, we have a picture of two congruent triangles. This is where we're going to start applying that knowledge. Use the following method to find the distance across the river from point N to point P. Place a stake at letter K on the near side so that NK is perpendicular to NP. So because NK is perpendicular to NP, we should see a right angle. Find M, the midpoint of NK, which means NM is equal to MK, and locate point L so that NK is also perpendicular to KL, which means that is another 90-degree angle, and L, P, and M are collinear, meaning they're all on the same line. Explain this plan, how this plan helps you find the distance. Well, first thing we start off is looking at those perpendicular lines. I know that NK is perpendicular to NP, and NK is perpendicular to KL, means 90-degree angles, which is also drawn. We know M is the midpoint of NK, so NM is congruent to MK. And if we look at our angles, angle LMK and angle PMK are congruent, because then that tells us we can use the vertical angles theorem. So then we can say that triangle LKM is congruent to triangle PNM using angle side angle. And we can also say that triangles are congruent. LK is congruent to PN, helps find distance across the river. Okay. Next up, we have our final proof, and what we're going to try to do is we need to prove that triangle BCE is congruent to DCE, and we know that angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Before we start any of this, it might be helpful to prove that side CB is congruent to side CD so that we can use side angle side, because we have these sides match and we know that DE would match BE. And we know that this angle here matches, so those are across from one another. So we need to be able to prove, can CB match DC, so that we can use side angle side theorem. Okay, so how we would do that is maybe start by setting up your proof. You have statements and reasons, and statement 1 is always your given. Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. Okay. Something else we can say, that we know that CE is congruent to CE, and we can say that that's reflexive. Then we can say that angle E is congruent to the other angle E, so that would be like angle DEC is congruent to angle AEB, and that is using the vertical angles theorem. So now we know that this is equal. So now we can say we have our side angle side theorem. So triangle BCE is congruent to triangle DCE using the side angle side congruence theorem. Okay, because now we have angle, a side, and then another matching side from CE, right? Okay, that will conclude our lesson today on 5.7. Check out your homework assignment below, and if there's any way this video helped you at all, please give it a thumbs up and tune back in next time when we continue learning about congruent triangles.